For decades, the story of how everything began seemed pretty clear. The Big Bang kicks things off, creating time and space. Then came a long, quiet period, the cosmic dark ages, where the universe was filled with a thick, neutral fog. After that, we figured the first lights would slowly flicker on, revealing small, simple galaxies, the timid toddlers of the cosmos. But the James Webb Space Telescope just stared into that ancient darkness, and it found something that, by all rights, shouldn't be there. An object so bright, so massive, and showing up so impossibly early, it's forcing us to rethink the very first chapter of the cosmic story. What Webb found isn't just breaking records, it's breaking our understanding of creation itself. So to really get why astronomers are losing their minds over this, we have to go back to what they expected to find. The standard model of cosmology, our roadmap for the universe's history, painted a very specific picture. After the Big Bang's initial fireball, the universe expanded and cooled. For hundreds of millions of years, there were no stars, no galaxies. This was the cosmic dark ages, a time defined by its lack of light, as huge clouds of neutral hydrogen gas filled space like a fog you couldn't see through. The theory was that eventually gravity would patiently start pulling together the densest clumps of this gas. Over vast stretches of time, these little pockets would ignite, forming the very first stars. These stars, called population 3 stars, would then clump together into the first proto-galaxies. According to our models, these first galaxies should have been tiny, faint, and chemically simple, made of just the light elements from the Big Bang, like hydrogen and helium. Heavier elements, like the oxygen we breathe or the carbon that makes up life, simply hadn't been made yet. That process takes time. It needs multiple generations of stars to live, forge these elements, and then die, seeding the cosmos with new material. The mission was clear. When Webb pointed its golden mirror to the dawn of time, it expected to find these faint baby galaxies. It was built to be the ultimate time machine, capturing the faintest, most ancient light, which is stretched by the expanding universe in the longer, redder wavelengths, a phenomenon called redshift. The higher the redshift, the further back in time we see. Webb was going to see those first flickers and confirm our story of slow, gradual creation. But that's not what it saw. In a tiny patch of sky, Webb locked onto a faint reddish dot. As the data rolled in, the science team knew they had something historic. They'd found a galaxy, now named MOMZ-14, with a confirmed redshift of 14.44. That makes it the most distant and earliest galaxy humanity has ever seen. The light from it traveled for over 13.5 billion years to reach us, giving us a picture of the universe when it was just 280 million years old, a mere 2% of its current age. It existed right after the cosmic dark ages, at the very dawn of time. But breaking the distance record was just the start of the shock. According to our models, a galaxy this early should have been faint and small. MOMZ-14 was anything but. It was, against all odds, incredibly luminous. The existence of such bright galaxies so early on was a stunning development that models had not predicted. It was like looking for a baby picture of the cosmos and finding a fully grown adult. And the surprises kept coming. As astronomers analyzed MOMZ-14 and other early galaxies like the previous record holder, JADE-Z14, they found something even more baffling. In JADE-Z14, which existed just 300 million years after the Big Bang, they found significant amounts of oxygen. This discovery was, in the words of the scientists, mind-boggling. To have oxygen, a galaxy must have already churned through generations of stars. Stars had to form, burn fuel, and then explode as supernova to enrich the gas around them with these heavier elements. For that level of chemical maturity to be there so early, star formation must have started even earlier and happened way faster and more efficiently than anyone thought possible. Some studies even indicate the presence of carbon and nitrogen in MOMZ-14, which would further accelerate this timeline. This single finding upends the timeline of cosmic evolution. It suggests the dark ages might not have been so dark for so long, and the universe was buzzing with star formation far sooner than we imagined. The existence of these impossibly bright and mature galaxies raised another huge question. How are we even seeing them so clearly? The early universe was supposed to be filled with that thick fog of neutral hydrogen gas, which is fantastic at absorbing and scattering the kind of ultraviolet light that young hot stars emit. Astronomers long predicted that even if early galaxies were forming, their light, especially a specific wavelength called Lyman alpha emission, should have been completely smothered by this cosmic fog. It would be like trying to spot a candle flame in the densest fog imaginable.
Yet in another game-changing observation, Webb detected a powerful Lyman alpha signal shining brightly from a galaxy named Jade's GS Z13-1. Seen just 330 million years after the Big Bang. Scientists describe this result as totally unexpected and were caught completely by surprise. For that light to travel across the universe and reach Webb, it means the fog must have already cleared out in large pockets around this galaxy. This find challenges our entire understanding of a crucial event called the Epoch of Reionization. This was the period when the first stars and galaxies produced enough radiation to ionize the neutral hydrogen, essentially lifting the fog and making the universe transparent. Scientists thought this was a slow, gradual process that finished about 1 billion years after the Big Bang. But Webb's discoveries suggest some galaxies were so powerful they carved out massive transparent bubbles around themselves much earlier than predicted. This forces a major rewrite of the reionization timeline. The first galaxies weren't just surprisingly mature, they were powerful enough to reshape their entire environment at a shocking speed. What we're talking about here is science history being written in real time. It's all thanks to the incredible power of the James Webb Space Telescope. If you find this trip to the dawn of time as mind-blowing as I do, make sure you're subscribed to the channel and ring that notification bell. Every new image from Webb brings us closer to the biggest questions there are, and you won't want to miss what it finds next. So, what does this all mean? We have galaxies that are too bright, too complex, and shining through a fog that should have been too thick. Taken together, these discoveries don't just add a footnote to our old theories. They're calling the entire picture of early galaxy formation into question. The neat, tidy story of gradual creation is being replaced by a far more chaotic, energetic, and rapid one. The models that predicted small, dim galaxies simply can't explain what Webb is seeing. The existence of objects like MOM Z14 and Jade's GS Z14-0 suggests the processes of star and galaxy formation were way more efficient and explosive than we ever imagined. This has sent theorists scrambling back to the drawing board to figure out how the universe built such massive structures so quickly. A few new ideas are taking center stage. Maybe the very first stars were far more massive and brilliant than we thought, letting them cook up heavy elements and ionize their surroundings at a furious pace. Or maybe the early universe was much more dynamic, with frequent galactic mergers fueling these wild bursts of star formation. Some scientists have even suggested these findings could point to new physics, or that we may need to revise core parts of the standard model of cosmology itself. What's certain is that we're in a new era of discovery. Webb isn't just confirming what we know, it's showing us how much we have left to learn. And this isn't just about one or two oddball galaxies. Projects like the Cosmos Web Survey are mapping huge sections of the early universe, releasing data on nearly 800,000 galaxies and showing that these bright, early objects are more common than expected. We are building a new, more detailed map of our cosmic origins, and it's proving to be more spectacular than we dared to dream. The James Webb Space Telescope was sent to look for our origins, to find the first light that broke through the cosmic dark ages. It has succeeded beyond anyone's wildest dreams. But instead of the simple, quiet dawn we expected, it found a brilliant, complex, and dramatic sunrise. It found galaxies like MOM Z14 that defy our explanations and force us to think bigger. We are living through a revolution in our understanding of the cosmos. The story of creation isn't a gentle, slow-paced tale. It's a story of rapid, explosive growth, of impossible complexity emerging from the darkness. The stunning discoveries from Webb aren't an end, but a beginning. They've opened up a whole new set of mysteries. How did galaxies get so big, so fast? What powered this incredible cosmic evolution? And what other secrets are still waiting out there in the deepest,
darkest corners of time.